This lecture covers the top three layers of the ISO OSI model: the application, the presentation, and the session layers. Layer 7, Layer 6, and Layer 5. The application layer. It is the interface between the user, the human user, and the rest of the 7 layers. It's an interface between the user and the lower layers of the ISO OSI model that translates and tries to make it easier for the lower layers to execute the orders and the requirements given by the user to the network. The application layer is responsible for the preparation of data for each service. Each service on the internet requires data to be prepared in a certain format, to appear in a certain way. For example, the web browser lets the data appear in the form of text, images, and hyperlinks. Another service, like the file transfer service, the FTP, requires data to appear in the form of solid files. Another service, like the email service, requires data to appear in the form of messages. The preparation of data for each of these services is responsibility of the application layer. The application layer is the goal of the 7 layers: to perform end-to-end communication on both sides between the application layer at the sender and the application layer at the receiver. This is the logical connection that needs to be established between the sender and the receiver, as if the application layer here is talking directly to the application layer there, as if there were no other layers interfering. The end-to-end communication on both sides of the sender and the receiver is the goal of the 7 layers. Providing end-to-end communication between the application layer here and the application layer there is the reason for the existence of these 7 layers. The application layer, the 7th layer in the ISO OSI model, is the layer where the software application resides, where the program you are dealing with as a user exists and takes from you the data that needs to be sent over the network and passes to the lower 6 layers, starting from presentation and ending to the physical. The application layer is the actual layer that sends the requests at the sending process, and the actual layer that receives the reply at the receiving process. It's the layer that takes the request from the user, passes to the lower layers, and receives the reply arriving from the lower layers and presenting it to the user in a readable and understandable form. Example protocols that work at the application layer are the following: HTTP, Hypertext Transfer Protocol. This is for web services. FTP, File Transfer Protocol. This is for transferring files between sources and destinations over the net. SMTP, the Simple Mail Transfer Protocol. This is for the mail exchange over the internet. POP3 is the Post Office Protocol. SMTP is for exchanging email messages among the mail servers. POP3 is for exchanging email between the client and the mail server. IMAP is Instant Message Access Protocol, is also for exchanging email messages between the client and the mail server. POP3 allows for downloading email messages. IMAP is only for accessing and reading email messages. Telnet and SSH protocols are for allowing for remote administration between a client that exists in a certain machine over the internet and a server that exists maybe 2 or 3 countries away on the internet, and the user sitting on the client software acts as if sitting on the keyboard and the mouse connected directly to the server machine and can do whatever he likes on the server machine through this telnet application. The domain name system or the domain name server, the DNS, is the protocol responsible for resolving the domain names into IP addresses and vice versa. It's the protocol that allows for writing www.yahoo.com and then connecting to a certain machine with the IP address corresponding to this domain name server. The RTP protocol, the real-time protocol, is responsible for transferring data that are real-time data, such as the audio and the video. Real-time transfer of data has certain requirements for certain data that are delay sensitive and not sensitive to losses in the same way that they are sensitive to delay. So the real-time protocol, which is somehow a new protocol, is responsible for transferring data of such kind. The presentation layer, or layer number 6, is responsible for the common representation of data between any source and any destination. It is responsible of presenting the data to the application when receiving, and receiving the data from the application when sending, in a certain form that can be understandable by both the source and the destination. It provides the transformation of data. It supports a standardized application interface at the source side and at the destination side. It is responsible of coding the data syntax. It's responsible of coding the data according to a certain syntax that is understandable by both the source and the destination. It is responsible for the encryption at the sender side and the decryption at the receiver side of the data being transmitted. It is responsible of the compression at the sender side and the decompression at the receiver side of the data being transmitted between the source and the destination. The session layer, or layer number 5, is all about managing the session, starting by establishing the session in itself, managing the session while it is running and up, controlling the session while it is transferring data, and at the end of the session it is responsible of how the session can be terminated safely. If we look at this diagram, we can see that the session layer sends some data that is like some data or like some sentences we use between each others as human to start conversation. If you say to someone, I'd like to send you something, and he says, sounds good, this is a request that is replied by an acknowledgement. This is an establishing to a connection. These two messages are the responsibility of the session layer to transmit and to acknowledge at the beginning of the session. At the end of the session, when you send your data completely and entirely, you say to the receiver, thank you, and he acknowledges you by the sentence, you are welcome. This is closing the session safely and closing the connection safely. Of course, in between these two messages, in between these two diagrams, the session can be stopped and can be restarted and can be resumed at a certain point of time. The flow of data can be controlled and can be slowed down and can be set to a faster speed. All of these functionalities are the responsibility of the session layer. It is responsible of managing the session as a whole, from the establishment by some handshaking between the sender and the receiver till the termination by some handshaking and acknowledgement between the same sender and the receiver, and through controlling the session in between while the data is being transferred between the sender and the receiver of the data. The session layer makes sure the connection is active during the session and makes sure that it is not falling down. It is responsible of securing the connection. It is responsible of the synchronization of the dialogue, the synchronization of the sending and the receiving of data. It is responsible of checking for the connection failure if existing during the session. which leads to losing data and which leads to slowing down the data transfer process. It's responsible for reconnection if there is a cutoff during the sending of the data or during the data transmission. Reconnection or resuming the session is the responsibility of the session layer. It's responsible of terminating the communication at the end of the session after all the data has been received by the receiver. The session layer defines the node communication order and timing. Order and timing are the core of the synchronization of the data sending. This is the responsibility of the session layer as well. The three layers, the application, the presentation, and the session, are very closely connected. They are very related in function to each other. That's why they form the application layer in the TCP/IP. If we have a look at the TCP/IP protocol suite, we can see that the application layer, the presentation layer, the session layer in the ISO OSI model are all compact and linked together in one layer in the TCP/IP that is called the application layer in the TCP/IP. This makes the TCP/IP only 4 layers, not 7 layers. Those 3 layers are responsible of content formatting, are responsible of formatting and representing and preparing the data being sent from the sender to the receiver. It's preparing for the network process, preparing for addressing, preparing for routing, and preparing for establishing the connection for the data to be transmitted through the network layers that lies down, starting from layer 4 until the physical layer in the ISO OSI model. By this, we have introduced those important 3 layers. Thank you.